the entire cargo resupply service turned out to be fairly international for orbital ATK. From the rocket that included engines that were initially developed in Russia, and a core first stage that was developed and built by Yuzhnoye in Ukraine, to the spacecraft itself that used a pressurized cargo module developed and built by Thales Alenia in Torino, who had the heritage of developing the MPLM and several of the modules on the International Space Station. So they understood what it took to build a good module. Some of the components of the Cygnus itself were developed and built overseas, and we purchased those because they were the best available and the most cost-effective for the system. We firmly believe in Buy American, but we also believe in safety first and mission success. And so we try to get the most cost-effective solutions we can. As we've evolved through the program, by the way, some of these systems that were initially purchased overseas have transitioned to American systems because American industries said, we're not going to stand for that. We'll develop these systems. We'll make them lighter, more cost-effective, and just as good as anything you can buy overseas. So we're starting to see some of that happen too. But in terms of the international flavor, it follows the theme of the International Space Station itself, which uses components from all over the world, many of which don't actually see each other until they touch in orbit and are never actually tested together on the ground except on simulators. We had the same thing on Cygnus. The CBM and the pressurized cargo module, of course, never touched the node until they actually got there, so we had to make sure that they were compliant, that they met all the requirements. Dealing with the international team that was building them and putting them together. I think there's that's a great feature of a program when you've got international buy-in. But we also learned some things along the way that were very interesting when you talk about legacy. That legacy is a two-edged sword. The Thales Alenia, who built the PCM, also had built the node and Columbus and other modules to certain standards that were paid for by the governments and were not commercialized necessarily. And so they had a whole list of requirements that they had to meet, and not just for the technology, but also for reporting and for safety certification and other aspects that required a lot of review by various customers. When we first contracted with them for the PCM, we got a decent price, but not what I thought was the best price possible. And it turned out they were trying to comply with all their legacy requirements all along the way, assuming that we would have to comply with them with NASA. And as we went through the program, we realized we were overachieving. And they actually could take responsibility for certain aspects of it more cost effectively than having to report it to either ESA or the Italian government or to NASA, and still get just as effective and safe a system. So we've been able to gradually reduce costs on the system as we went forward. During the development of the Cygnus spacecraft and the overall CRS system, I was the Deputy General Manager for the Advanced Programs Group, and at that time Orbital Sciences, and directly responsible for the development of the program, and even for a while for the Antares launch vehicle. And so I spent a lot of time with program management, reviewing where we were, who we were buying things from, how the development was going, what testing was coming up. And then when appropriate, I would visit the suppliers that were involved, particularly ones that might be having problems, or by the same token, ones that were doing really well, to let them know we were proud of what they were doing and we appreciated their efforts, particularly when they were solving problems on their own rather than requiring a whole lot of assistance from us or NASA. We treated them the same way NASA treated us, by maintaining insight and, where necessary, oversight for system performance, but also relying on their expertise because many of them have been doing it for years, if not decades, and we're very successful at it. So I thought it was a very good partnership, and we had good relationships at the top, but we also had very good relationships in the middle, where the real experts were working the problems out and dealing with the interactions, and established a lot of rapport amongst themselves, which made it easier for the executive team to actually agree on how we were going to go forward, and also how we were going to share risks. And I felt that there was a lot of risk sharing going on with the suppliers, both domestically and internationally, and that was another key to the program where we knowingly and where necessary on paper shared the risks going forward, because we knew in the end we'd have a more cost-effective solution and something that we thought would sustain, meaning that NASA would buy a lot of these and we'd have a business that would go on for quite a while.